So now I'm going to move on to the microcystin detection model. This is again a logistics regression framework, and so here we're looking at the probability of detecting microcystin at that 0.1 micrograms per liter. And so here's the table. Again, I've broken it up into those buckets of covariates that I shared with you before. You'll see some very familiar things in the top part of this table. So total nitrogen, nitrate, and pH have the same relationship with microcystin detection as we had with cyanobacteria. Now we're looking at the evaporation to inflow ratio, but again, this is kind of a similar metric to just the evaporation on its own. So in situations where either you have a lake that has a very high degree of evaporation happening in it, or a very low amount of inflow coming into the lake, that gives you a higher risk for microcystin detection. In terms of nutrient inputs, we're seeing both agricultural and developed cover in this model was important. In terms of climate and setting, interestingly, temperature and precipitation didn't end up being super important in this model. I left temperature because it was like kind of at that level where like, yeah, maybe it's important. It seems to be improving the model a little bit by having temperature in there, but this is interesting and sort of gets into something that Laura has really turned me on to, is that the factors that lead to toxin production may not be one and the same as what leads to cyanobacteria. It certainly can help, but it's not necessarily enough. Also, base flow index appears here. So this gives us a sense of how much water you have sort of coming into the lake on a regular basis without accounting for storm flows. And so if you have really high base flow conditions in a lake, that tends to be a lower risk for microcystin. And then a couple of factors, depth, also negative, and fetch, which is a positive relationship. So that kind of gives you a sense of the array of things that across the US are sort of leading to these patterns. How well did we do? The fit has to be assessed a little bit differently because we're looking at probabilities rather than a linear model. And so what I'm showing you here is the fitted probability associated with each of these observations and whether we observed microcystin as present or absent in any given observation. And you can see that the fitted probability is a lot higher when microcystin is present in that sample. So we're excited about that. And we assessed overall model fit using the area under the receiver operating curve, or AUC, and that's 0.9 for this model, which is out of this world. I did not anticipate being able to perform that well. And again, we also ran this model with a non-spatial component, and that performed a little bit worse. So we are seeing that having this spatial modeling framework is giving us a little bit of a benefit in putting these models together. So that's just some very preliminary stuff. I'm going to kind of distill the salient points. There were some similarities and differences between these two things. So, you know, in-lake conditions probably represent more when you're having an active bloom versus when you're not having an active bloom. Whereas we really had to look to sort of more of those land cover variables to get a sense of kind of what are the longer term nutrient and context situation for each of these lakes. We found that lakes that are shallower, that had higher evaporation rates, lower base flow or lower inflow altogether, those tended to be at higher risk for both cyanobacteria and microcystin. And across these data sets, we found that the Western had a lower overall response. But again, want to emphasize that that's just in this data set and doesn't mean that it's not a problem here. Some of the differences are that, you know, the climate was relevant to cyanobacteria, but not so much to microcystin, which is kind of interesting. There was also a lot more spatial correlation in the microcystin model than there was in the cyanobacteria model. That result is, I don't know how much I trust that result, but that's what it's saying so far. And I thought it was also very interesting that DOC was negatively related to cyanobacteria. But again, one of the things is that when you go out across the country and sample 1,000 lakes, you can end up with some lakes that really just staggeringly high DOC concentrations that may or may not have high cyanobacteria. But in our data set, they tend to not. So where are we going? this is where we are currently with kind of those 4 sets of variables looking at the CyanoHABs. We have kind of this everything in the pot situation right now. Our next step is to remove that in-lake part of the information, because that's while super useful to understanding when and where HABs are going to happen, a lot of times we struggle to get that information for a large number of lakes. And we have information in these other buckets about the nutrient inputs, climate setting, and lake morphology for many more lakes across the country. And so the idea is that once we have these models together, then we can apply them to understand the CyanoHABs risk at a much larger number of locations. So that is where we are headed. Thanks again for sticking around and for your attention, and I'm happy to take any questions.
Let's talk of the meeting. Well, we will have people stick around and ask questions of Amalia and previous speakers. So I'll have time for that. You can stay as long as you want, but feel free to leave if you have other time constraints.
Thanks, Dan.
Yep. Question.
Yeah.
So, and I think you've done this in the past, but I presume there's you have overlap of where you detect microcystin with the satellite data. And I'm just wondering, by having satellite information or detections, how does that increase your odds of detecting microcystin? Like, I'm thinking about like in a Bayesian context.
Yeah, so are you talking about like integrating the satellite data in with the national lakes data?
Yeah, what I'm saying is, you have a set of lakes where you have microcystin detects. You presumably could overlap with that with the cyan data to see where you're having either hits above a threshold or detections. And theoretically, that should increase, the satellite data should increase your odds of detecting microcystin. I'm wondering if anyone's done that, or if maybe you have, and I just think.
Yeah, that was really our first analysis that we published last year, which was overlaying the National Lakes Assessment data with the Cyanobacteria Assessment Network data. Yeah. And we did find that there was a relationship. So if lakes had higher cyanobacteria over time and across the lake area, basically those lakes were at higher risk for having microcystin detected in the NLA. And so we were able to quantify that relationship and then say, okay, for all of the cyan lakes, based on their bloom magnitude from the satellite information, what's their risk of microcystin detection and microcystin at 1 microgram per liter. And so we were able to do that on a spatial, across the lakes, across the country. I wouldn't advocate for applying that model within a particular lake, at least not at this time. In terms of having that additional information, that is one of the challenges of working with the National Lakes Assessment data, is that it is one sample that's collected one time over the summer. And we have done some work with that to see how robust those measurements are, because some of the lakes included in the model is about, let's see, we have, I think, about 3,500 observations across the 3 NLA cycles that we're working with. And it's about 2,500 lakes that are included in that data set. And so we are able to do some analysis to see how consistent are lakes over time, both within a summer and across surveys. And the answer is kind of remarkably similar, which is surprising given all the internal variability. But again, that's a question of scales. When you're looking across the US and at a survey that's a representative sample of lakes across the US, of everything that experiences blooms all the way to lakes that don't experience blooms, then maybe it makes sense. Yeah.
I'm super curious. Well, first of all, really cool work. And I applaud the idea of dropping some of the variables that are going to be harder to get and trying to build out from there with less info. I think I am really curious how tau is formulated in the model. Is this, I'm Latin long, it would be the simplest, but I'm assuming.
Yeah. So I really have to refer you to see the documentation on the R package that we use for that. That's built by my colleague at the EPA, Michael Dumel. And he built out a package in R that that would implement spatial models using a very similar methodology for the user that feels a lot like I'm just running a regular old GLM, general linear model. And so I would have to refer you to Mike to talk about some of the details, but basically my understanding is that the model, how it works is that it basically looks at your covariates that you supply to it, and it partitions variation to each of your covariates. And then it takes the leftover variation and it says how much of this is potentially correlated in space. So it knows the location of each of the observations in the model. And so then it does math magic and figures out how much of that leftover variation has some spatial dependence associated with it. And then anything else is sort of determined to be an independent error term. Yeah, but I'm happy to share with you the documentation on more about it. Yeah.
Adam,
Yeah.
The cyanobacteria abundance was negatively associated with precipitation, and I'm thinking of how many ways precipitation can impact water quality. Is there a single factor that you think is impacting it the most, or is it more indicative of like?
Yeah, so I suspect that, I mean, because what was included in that model was the 30-year climate normals, my suspicion is that that really ends up being a marker for if you're in a place that's drier versus wetter, kind of what the sort of baseline cyanobacteria risk is for that particular region. So we don't have even one layer more, or we could, to say, okay, how much of that precipitation is snow versus rain, and what time of year is it coming into the system? Because the National Lakes Assessment is data that's collected over the summertime. And so we all know that we live in a place that can be quite wet certain times of the year, but not necessarily during the summer. And so I think that that's a great question to think about, kind of what are the different precipitation levels.
Great, thank you.
Yeah.
We want to give a chance for folks online, if anyone has any questions they'd like to pose to Amalia or any of our other speakers.
Very quiet for the first time.
Everybody run your other minute.
Okay, I appreciate it.
Hey Kurt, have you got a question for yourself?
Actually, one question I do have is, so for this model, the work that you're doing, who do you envision as the end user for it? In terms of, if you're building this out, and, you know, I work at a state regulatory agency, and I'm wondering how I can take something like that and implement it in the work that I do.
Yeah, so there are a couple of different things that we're thinking about as like follow along analyses, and most of them are like future sort of national scale projects that we have in the works. So in terms of the end user, you know, I hope that we can generate a map that, you know, has CyanoHABs risk with respect to cyanobacteria and potentially microcystin across the US. As we've learned today, microcystin is not the only problem out there in lakes these days. So I acknowledge that, and that's why I hope that the cyanobacteria models are still useful. And so one of the things that we're kind of interested in doing is looking at sort of like based on monitoring programs. I hesitate to use the term validation because these are really different data sets from each other, but just getting a sense of how much agreement is there between our national models and kind of what folks are seeing on the ground. And I've talked about that with Rochelle because I understand that many of the blooms that they've been experiencing in Washington happen quite a bit later than the National Lakes Assessment Index period, which ends in September. So that's one potential use of it. Another thing that that we have in the works with Office of Water and and I also have a research project on this front, is to use these risk estimates to try and start looking at the communities that are near these lakes and asking, what are the demographics? Are communities already dealing with environmental problems? Are there distributional justice concerns associated with cyanoHABs? And so I have another colleague who's also working on this project with us, Michael Panino, who I think you're familiar with, Michael. But he's interested in using this work to, and hopefully very soon, we're gonna have public drinking water service areas across the US. And so he's very interested to kind of connect our risk information with those drinking water service areas. And then he also has somebody who's working on compiling just an incredible amount of information about treatment technologies for those public drinking water areas to try and understand what are the potential risks to drinking water for communities across the US. So those are some of the ways, but if you're interested in working with this type of data, like we'd love to see it used once it exists, of course, and is reliable.
No hands up. Might be time to adjourn.
We wore everyone down.
Well, thanks everybody who presented today. Thanks to everybody attending here and on Zoom. We've recorded the entire session that will become available within the next week, and the slides. So we'll send out a notice about that. The next event will be in 1 year's time, probably very similar to this. So you're all there.